Hey everyone, hope you're doing well. I have a quick lesson for you today on balancing chemical equations. And getting good at this skill will be very important if you move on to higher levels of chemistry. Because what a balanced chemical equation tells you is it tells you how much product you'll get based on how much reactant you start with, right? So if I look at my first unbalanced equation, which is just hydrogen and oxygen combining to form water, without this equation being balanced, I don't really know how much water I'm going to get based on an initial value for hydrogen or oxygen. And the way we balance an equation is we try to make the number of elements match on the left side and the right side. So we have two hydrogens, and that's because obviously we have the symbol for hydrogen here, and then we have a small 2 showing that we have two atoms bonded together. So I've got two of those, and then same deal for oxygen. We've got two. Looking at our right side, we also have two hydrogen atoms, but we only have one oxygen. So this pair looks good, but this one not so much. So we need to do something for oxygen. And the only thing I can really do is put a 2 in front of H2O, because what we're going to do to count the number of atoms that we have is we're going to multiply this number in front by the small subscripts for each element. So when an element has no subscript, we can just assume it's a 1. So now I have two oxygen atoms here. And for hydrogen, I'm going to have to multiply its small subscript by 2. So now if we update our right side, we have 4 hydrogens and 2 oxygen atoms. So now we've fixed the oxygen, but our hydrogen is now a bit off. Luckily, the way we can fix that is just putting a 2 on our left side to counteract that change. And that's really the core skill that you need to learn when you're balancing equations is when you make a change on one element or compound, knowing how to balance some of the other elements or compounds that get shifted because of what you just did. And we'll get some more practice on that in the second example. So let's do the same breakdown of our left side and our right side, just to start off. Left side looks like we have 2 chromium atoms, 7 oxygen atoms, and 1 hydrogen. On our right side, we are starting with 1 chromium atom, 1 oxygen, and 2 hydrogens. Now, when we're dealing with a lot of different elements, personally, I like to start looking at oxygen and hydrogen. I find that tends to help out with simplifying things. So let me start with oxygen. The only thing I can change on my right side to increase the oxygen would be water. And I have a difference of 7 to 1, so I'm going to put a 7 here to make sure I have the right number of oxygens. But what that does is it increases the amount of hydrogen I have, because now on my right side, if I take the big number here, 7, multiply it by my small subscript, 2, I have 14 hydrogen. So what I can do is I can balance that on my left side here. And then to balance chromium, it's just a 2 to 1 ratio. And I have chromium by itself on my right side, so I can balance that with a simple 2 here. And at the end, if you want to double check your work, you can just quickly count things again. So 2 chromiums here, 2 here, 7 oxygens, 7 oxygens here, and finally 14 hydrogens on the left and 14 hydrogens on the right. Okay, Let's try a acid-base neutralization, because this is a super common type of reaction that you'll see in chemistry. And same deal as before. Let's count what elements we have on our left versus our right. I'm counting 1 hydrogen from my hydrobromic acid and then 2 hydrogens from my magnesium hydroxide, right? Because when we have these brackets around the hydroxide, or any ion really, and then we have a small subscript, this 2 is being applied to everything inside the brackets. So that means we have 2 hydrogens and 2 oxygens just from this 1 magnesium hydroxide. Anyways, that tells me that we have 2 hydrogens here. So 1 from my acid, 2 from my base. That gives me 3 on my left side. What else we got? We have 2 oxygens, as mentioned before. 1 bromine and 1 magnesium. Okay, now for our right side, from our water we get 2 hydrogens, 1 oxygen, 2 bromines, and 1 magnesium. So the only one that's good on its own is magnesium. We have 1 on both sides. Let's look at oxygen now. The only way I can increase oxygen on my right side to match the left side is if I add a 2 here. So now my oxygens are balanced. However, now I've got 4 hydrogen on my right side, but only 3 on my left. What I can do to fix that is put a 2 on my hydrobromic acid, and now I can check to see if everything looks balanced. So I'm going to update my numbers with what I just did and see if it works. 2H from hydrobromic acid, 2 from the magnesium hydroxide. That means we now have 4 on our left side. And on our right side, we have 4 from our water. So that looks good. Oxygen was the first thing we did, and we just doubled it on the right side. So that looks good too. That's a match. And finally, we have 2 bromines now on our left side and 2 on our right side. So now this whole thing looks balanced. That's really the gist of it. And the way you're going to get better is honestly just to practice with different kinds of questions, more complex questions. And I'll give you a quick idea of a tougher question. And the same rules apply. It's just more complicated because we're dealing with so many different compounds and elements together. So let's follow our usual routine of breaking that down the left side and right side. We've got 1 potassium, 1 manganese, 1 chlorine, 1 hydrogen, and 4 oxygen atoms because of the subscript down here. So left side looks okay. Right side's a bit more complicated. Let's see what we're working with. Right side, we start with 1 potassium from our KCl, or potassium chloride. Manganese is also 1. For chlorine, I see 1 here, 2 here, and 2 here, so that's 5. For hydrogen, we've just got the 2 from our water, and then oxygen is just 1. So a little bit more complicated, but I'm going to continue on what I said before, which is focus starting with the hydrogen and the oxygen. I'm going to do the oxygen first. I've got 4 on the left, 1 on the right. The only place I can increase my oxygen is with water. So let me put a 4 as a placeholder there for now. So now the oxygen is balanced, but I've introduced quite a lot more hydrogen because now I have 4 times 2 hydrogen atoms, which would be 8. So the only way I'm going to be able to balance that on the left side is to put an 8 here. Okay, that helps with hydrogen, but now I've introduced a bunch of chlorine. I've got 8 chlorine atoms on my left. I need to try and make 8 on my right. I have, again, 1, 2, 3, 4, 5 chlorine atoms. And my calcium and my manganese is already balanced. So I don't think I want to affect these two compounds, because if I put a coefficient here or here, that's going to mess up another element as well. So I want to directly affect only chlorine here. But I don't think I can make a perfect 8-to-8 match, because I have 1 here, 2 here, that's 3. And then if I wanted to make an 8 with a subscript of 2 here, I would need to put a value of 2.5. And this is actually a good example because you do not want decimal values in your coefficients when you're balancing equations. So even though this makes mathematical sense, right? Like if I multiplied 2.5 by 2, I would get 5 atoms of chlorine. It won't work to actually balance the equation. But not to worry, because everything else works out, if I just multiply all of my coefficients by 2, I should get the right answer. And what that does is just eliminate the decimal in our coefficient. So 2.5 times 2 is a 5. Put that there. 4 times 2 is 8. 2 times 1, because when the space is blank in front of the element or compound, we assume it's a 1. So 1 times 2 is 2. Same here. 8 times 2, I'm going to need to change this to a 16. And finally, 2 times 1 is 2. And that looks like a perfectly balanced equation. So try a few of these on your own. You can try simple ones. You can go right off the bat on something like this and really cut your teeth on it. But at the end of the day, it's just practice and getting familiar with how we can manipulate the coefficients to balance our left side with our right side. Thanks for watching, and good luck.